Mic check. Alright, we are live. So, yep. Let me just fix a few things here. Okay, so yesterday we finished refactoring this cube to panel to cube map pipeline, and yeah, we encountered like we had 3 questions. So I promised that I would investigate on those, and I did. I did just that then. So let's see where our questions were. Okay, can the sampler uh, yeah, can we add this sampler later on directly to the descriptor set descriptor? So I asked this, and the answer is yes. Yes, you can. So we had a few questions, few follow-up questions relating to this. So the way that we would do this, adding samplers later on, was here via the descriptor set descriptor, and the way that you would go about doing that, let me see. Yeah. So rule signature get, that is nonsense. I don't care about that. Mm, not here, but later on, right here. So we could like update our descriptor set here and use this parameter, this descriptor data parameter. It has some sampler, an array of sampler. It can have an array of samplers in it, and we could perhaps like update our samplers there. So that is the other way of doing that. But the question arises here is as to why do we have two interfaces to do one thing? And the answer to that is because the GPU vendors are now providing methods to like set these samplers as a constant variable, like a constant variable inside your shaders. So that would like reduce the amount of work that you would need to do at runtime. So there, since samplers are usually not that frequently updated, so that that, this interface allows like reduction of runtime work, like not the runtime work, all of it's runtime work, but rather the pass path, the work that you would do in your pass path. So you would need like two interfaces, one for like when you want to like initialize this sampler and let it be, and don't update it later on. So this path is for that, and the other path is for when you need to actually update it every time, which is for textures and stuff like that. So yeah, that is why we have two interfaces here, and that is true. Our sampler here is only set once. Not here, but here. It is only set once. It is, as you can see, it is called static sampler. It is not changing at runtime. And yeah, that is how it is being done here. But one question that still remains is that where we actually need this root signature here to like get our output descriptor set. One thing that I realize is that, let me see, here we're not talking about the shader, are we? We are. We have the shader here. So interesting thing. Oh, that's not interesting. That's just natural. Yeah. So yeah, we're adding the root signature here, the descriptor, and that's that. So my question would be whether this can be null footer. Let's try that. I think it wouldn't be because it has a shader in it. There is a shader in this. So, or could we? Where's our update? So the only place that we are passing the shader to our descriptor set, that is here. So I can that's why we're passing it, but we're passing also some other stuff like the sampler as well. That's not preferable, but that is how the interface is. So interface is a bit wacky here. So I guess that is what I'm going to do tomorrow. I will just send them this piece of code and tell them that this could be fixed there. This could be done better. Yeah, that's fixed, of course. Yeah. All right. So one other thing is, can we actually avoid this update here? For this, we need the update because our parameters are actually changing. But for this one, our parameters are not going to be changed. So maybe we could do this update like in the construction. It doesn't really matter though. Like it would be almost the same. All right. Let's see what we're going to do today. So we got a good understanding of this. We know all that. Find push constants. All right, we know that too. So they linked me a part of their. So they do have some like a bit of documentation, and they linked me that. Let's read that together. So this is a descriptor binding interface. So descriptor binding is handled through descriptor set interfaces. Descriptor set represents a bunch of VK descriptor set for Vulkan, D3D, GPU descriptor handle for D3D12, and the corresponding metal one. So there are three ways to bind descriptors. So these are actually what we are seeing there. So descriptor set, which is what we just discussed, and push constant. That is what we have here. This is command push constants. In order to specify a shader resource as a push constant, the word root constant, case insensitive, should be somewhere in the shader resource name. Let's see that root constant. Alright. Example. Constant buffer uniform block won't be interpreted as root constant. However, root constant block will be interpreted as root constant. That is weird. Why would they use such a thing? Like I believe there are layouts. Let's see. We do not have a shader open already, right? So data constant buffer root constant. There. Register B0. Is this just telling it to put it in the B0 register? That is weird. And push constants are useful for specifying per draw data. So that is the data we have on each draw call, such as a draw ID, and are very fast to access from the shader. To bind push constants, use the command push constant function we have here. There. Right, root descriptors, dynamic uniform buffers. In order to specify a shader resource as a root descriptor dynamic uniform buffer, the word root CBV case insensitive should be somewhere in the shader resource name. Root CBV. We don't have such thing here. Root descriptor. That is not something we have here. Is it? Root descriptors enable us to bind different offsets of the same constant buffer. To bind different offsets of the same constant buffer, uniform buffer, to the shader without having to call vk update descriptor set. Copy descriptor set simple. They are also faster than regular uniform buffers, since they get user data placements. To update root descriptor offset, call the update descriptor set. We have this. Why is it not? Isn't this visual like this? What is wrong with Visual Studio is going down on me? Do we have a typo here? I believe not. Alright, sorry about that. My voice is a bit scratchy. Let me drink something. So yeah, we're updating it here. That is our parameter. We're updating our texture through that. But our texture doesn't have this root CBV thing here. With new offset and size. Has this become deprecated, or is that a bug in the system? That's another question here. So let me just remove the answered questions. Sorry about my voice. Why does the name not contain root CBB? And the other question was, can we make this interface simpler? Why do we need to pass it a root signature? And our answered questions are gone, and we have two new questions, which I will be asking them. So this is nice. We're understanding their interfaces. This is going to be essential for our later steps, when I'm going to start like aggressively try to uh like refactor their engine code, their actual code. That is going to be useful for them. So yeah, that is part of my question there. I'm just assuming, by the way, that this destination texture and source texture thingy are used, that they are actually uh, dynamic uniform buffers. Let me check the shader again. RW2D float 4 destination texture. These don't look like uniform buffers to me really. Let me open the Vulkan version. I'm not really comfortable with DHLSL. Uh, which one was it? Panoramic to CubeMap. That is the one. Alright, this is the Vulkan version. And layout. So these are actually uniform buffers. Both our samplers, everything is uniform buffer. And this is root constant here. Root constant. So maybe the code, this has just been deprecated, or maybe the code has gone out of sync. I will need to figure that out later. Anyways, so now we understand that part. Kinda understand that part. So we're updating these parameters here. That is how they're being updated. And then our dispatch command here. Let's see if they have specified update frequencies for descriptors in shader. Descriptor gets handily updated in the lifetime of application. Descriptor gets updated roughly once per frame. Descriptor gets updated per arbitrary batch. So I guess these are just for optimizing. Probably. To specify the update frequency of a descriptor inside the shader code, use one of the values from above as the register space in HLSL or set layout modifier in GLSL. So that is this. And there. Are they also like kind of processing these? Since I wouldn't think that. Yeah, they probably are being modified, pre-processed before they're directly passed to the shader, to the compiler, because like I don't think that these would be the same between HLSL and GLSL, or even the MSL. The interface, we have add descriptor set. Allocate a descriptor set with given description. This is that part of our code. Sets all the descriptor handles to default values. I also need to ask about the lifetime. Let's put that here as well. How are the lifetime of these related? What are the lifetime dependencies? Command descriptor set, bind descriptor set, bind the descriptor set, index to the command buffer. Save to call from any thread. Update the descriptor set at index with the provided array of descriptor data. Command push constant, that is what we saw there. And command, we don't have that. Descriptor set descriptor root signature. Root signature to use to create descriptor set. Why do you need a root signature? Descriptor set descriptor update frequency. That is what we have there. Max set, no index, we don't care about that. Descriptor data, so descriptor data. Okay, that is all we had here. We read the whole document. Triangle visibility, macro profiling, how to use input system overview, how to use the shader translator. Ah, they have cool stuff here. Shader translator. What does it do? Shader can be used in following ways. Install the extension located at blah blah. After that, we can directly use it from Visual Studio, which includes just right clicking shader, and it gives you the option to translate shaders. To use blah blah. What's do? Options. Define shader stages, define target language. So I guess this just translates one shader to the other. That is interesting stuff. Interesting. Alright, done with that. Let's move on. Let's move on with this code. Okay. I don't think there's any part of this code that we don't understand for now. So I'm going to skip over this and get to our draw call. So the interface seems kinda alright now. Let's see if there are any tricks in the draw function that we don't understand. If not, I'm going to go like start a new project, just write something from scratch and see if we can actually draw something. And if so, then I will just get comfortable with it. Sorry about that. And then we will go to do our aggressive refactoring in the engine code. Acquire next image. So these are the parts that we haven't touched because we haven't been reading the draw function here. So pre-render swap chain. How do we get the swap chain? Image required semaphore and frame index. So we know what frame we are at. That is interesting. And this is 32-bit integer. That is gonna overflow, isn't it? Let's not worry about that for now. Let's see. see how our swap chain is made. Alright, at the load, we are using it at the load first. Of course, not the first. It's in the line order. It is not necessarily the first. What function is this? This is the draw function here. Where are we actually? Where is this? Create pipeline. Color buffers. Nope. We were there. We were there. Create render targets. Alright, we're creating a render targets here. Depth pipeline, depth peeling pipeline render, target descriptor. Where is this used? That is used here. Okay. What else do we have here? So let's see how we are creating a render. Just width, height, depth. How many depth we have? I guess how many depth buffers? I don't know. Maybe it's just a boolean. Alright, so that's that. I didn't read through. I read through it in my mind. So it's just simply describing every bit of render target. Interesting thing is the clear values, because as I know, those clear calls are done separately. So they're doing the clear call somewhere. Sorry about the voice. These are textures, and I believe they're going to be mapped to the render target. So we have a render target done here. That is, so where is the texture used? So here we are loading the texture. This is not nice, really. This kind of, that just bugs me. Like, do I read this? Do I not read this? When should I read this? Am I going to see code that relates to this? Where is this used? Texture load descriptor? Oh yeah, this is texture. Where is this used? Remove resource? Really, mate? And they're also using like they're using like different macros to disable and enable things. Like here they're using metal. Some other places they used iOS. I don't know if they actually mean the same or not. Gotta say I'm really not comfortable reading this. Okay. So they're doing different stuff for iOS. That is not how you handle. You're supposed to handle cross platform, but they're doing so. You know what? Screw this. Can I duplicate a project? Because I do not know like how their linkages working. I'm going to start like, yeah, this is not fun to copy from these, so I guess the best way to do is just copy one of these and start cleaning the code and writing something. That's what I'm going to do. Maybe it would be better if I opened it from here. All project, scan solution, display browsing, clear browsing, open folder in Product Explorer. That's how I'm going. And let's start with the easiest one, I guess. Let's see where their source files are. So from the next episode, I'm going to rename this, rename the title. I am going to start writing this example. So you're 30 minutes in. What I'm going to do today is try to just try to, what is it? Uh, get a new project running. Exclude from project. No, where is properties? Where is the path? Just tell me where the path is. Really, mate? You're not going to tell me where the path is? Okay, that is the path. Unit test, SRC, playground, blah blah. Alright, so that is what I'm going to do. Copy and paste these, rename it. How many do we have? How many? 31. And we have only 18 here. You know, example animation, example audio, render. Those are not example renders, those are our renders. Tools, Lua Manager, Superby Tools. Sorry about my voice today. My throat is really scratchy today. Anyways, mine is going to be added here. Severe tracing. Sorry, I'm getting carried away, but I want to see if my GPU supports this, or does this actually rely on ray tracing. It does work. Those are some fine looking shadows there. Those shadows look amazing. Jeez, look at that reflection. Oh god, this is so interesting. That is kind of a weird. That is kind of a weird. What is it? Weird clipping surface we have. It's not a surface. It's a sphere. It's a clipping sphere. That's why it feels weird. Those shadows look amazing. Those are really amazing shadows. Look at those reflections. Those shadows are failing here, you can see this object. They are not handling complex objects well. But in general, this looks amazing. Those are, if only you could like fix those artifacts you can see there. If only you could fix these artifacts. Why is this running? Graphics 12 milliseconds. So this is all almost at the edge of my processing power. It is 60 frames per second almost. Transparency, no. Toggle profiler, no. And of course, both are both 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 of our like clip and surfaces are spheres because I don't know why. These look amazing. Yeah, that's something I'm going to look at later. And the code isn't that much. The code is maybe I should have just started with this. Add swap chain. This is kinda more structured as well. Load exit. Okay, let's not get carried away with that. So we have 31. I'm going to add the 30 second example, and we're going to write the structured code. So that is what this is going to be, structured code example, and I believe I can apply. That's going to name that. I know these are going to like cause me problems. That is why can I edit this? See, that's how you fix code here. I could have opened this with VS Code. That would be better. It's not going to code. What is the name? Whichever filter. Let's start from physics. So I'm going to like simply rename these. That's how it's done. I'm just gonna add this example here. No, close that one. Nope. I'm gonna add this example to my examples list. And it is gonna have like several missing stuff, like it is going to say I'm missing this. It is null. Yeah, of course. So yeah, let's start fresh, I guess. I am going to make a folder here, a filter. As that, why am I so bad at using this tool? Maybe because I'm too distracted. New folder. Okay. Source. I think that is their structure here. Source files. Source files. Oh, come on. Alright, and something new as well. Shaders. And that is that. And in shaders, I'm going to support Vulkan for now. Or maybe the 3D. Let's go the 3D. What did I just? Well, alright. That is our new structure, our new project. Let's see where the code is. Example. Our code is going to sit here. 30 seconds. Example. Structured code example, I believe. Save this. That's nothing to save actually. Let's see what we have. Okay, I'm going to copy this one here, rename it, and use a bit of code in there. Oh, hold on. That is that. Adding. Removing everything. Those I may need. These I'm gonna need. Gonna need that. My memory must be the last included serial part. That is just nice. Removing those. Remove everything else. How many lines of code is this? So yeah, I'm removing everything. Just gonna get a get a simple pipeline running, like rendering uh rendering all white. Why not, huh? It's the structure. Let's make it class, no need to make anything public there. No, let's make it, yeah, let's make it class. I'm gonna specifically specify my public interfaces which I'm going to override. So public, there we go. It is going to inherit from IAP. That is that. Let's start writing. Should we? Let's first see if this actually compiles my code. Oops, oopsie doo. Nope, it is not. It's just telling me that I have to, I guess. Alright. Conversion from render byte to exist but is inaccessible. Oops. Yeah, this needs to be public. I wonder what this IApp thingy is going to do, provide for me. Can instantiate abstract classes. Alright. So I need to like implement some of these functions we have here. Let's copy them from them and empty out their stomachs. So maybe the better way of copy pasting it is this. I'm also realizing that I am on the wrong file here, so I'm going to copy this one here and change and revert all my changes here. Gone with that. This is our structure. This is our code here. Alright, let's put override final on all of these. So let's not make the mistakes we just found on the old codes. Also, all of these can be like, yeah, you don't have headers here. Nothing. Nothing. Those are what we are going to implement, and we need to have a body here because we need to return something, and that is the structured code example. Don't forget your semicolons. Let's see if it compiles. It is gonna compile, but I don't know how it is going to even run or not. Okay, my setup project was a different one. So this has is it? Where is it? I'm such a noob. Huh? Nope. Sorry about that. What is it saying? These should return true. Why not? We are well initialized. What else? Load return true. We do not have any errors at load process either. So we are 49 minutes in. Let's see what this code is going to do. Nothing, is that it? I guess that is it. So it just opens up a window for me. And there goes that. Okay, so let's actually do something. Let's actually start doing a bunch of things. So I believe we're going to need, yeah, this is a simple code here. I'm going to like try to, I'm wondering how we're going to manage our resources. Text resources, texture. So we have a bunch of resources here. We can use those. I'm not sure about what these are doing. So I believe the first thing we have here is a renderer, and it's a putter, but not every putter. It's a unique putter. EASTL unique putter. Also, I think we could avoid using EASTL, but let's not use EASTL for now. I believe all of their interfaces are actually C. So I believe I am going to be able to use normal STL for this. So I'm going to add unique memory. So I'm going to have stit unique putter. I'm going to ask them why they're using ESTL in their examples. And if it made sense, I'm going to use ESTL as well. Renderer. This is my renderer here. Alright. So we have a renderer, and you need to construct one. On construction, is it a valid code to construct my renderer at construction? That is something that needs to be asked. I believe it is, but they could be like uh, they're definitely inheriting from us. So our code is actually, no, we're inheriting from them. Mhm. At least we have some documentation here. Do they actually have an init app? I didn't see one. So yeah, they do not have an init app. That is weird. Documentation is out of sync, I believe. I shall maybe report that too. So let's see. So this is gone. This is gone. They do still have this, and seemingly they do not have settings with blah blah. So they do not have this as well. Load and unload. They have load and unload. Yeah, they do have both. What is this? The pair function leaves load and unload everything that need to be reloaded in case of a device change. So this is going to be called on device change. So there's a reason to put some stuff actually here. Device change can come from a user switching from hardware to wrap renderer, rendering support, or switching on and off MSAA and other quality settings. Typically shaders, textures, render targets, and buffers are loaded here. Pictures, shaders, render targets, buffers. What about the render? It's here. This is where we initialize the renderer and bind the OS and graphics API to the application. So this is what doesn't exist anymore. So I guess they are done here. And hot swap. We don't have this. This is input math update, everything CPU only. No graphics API called on update. And draw. This should be renamed to draw. Only graphics API draw calls and command buffer generation. Alright? Alright. I guess we're ready. I am guessing we're ready. So, we said that we were going to make our render here. Our render should be in the initialization part. So I'm wondering, like, what would happen? Ah. So that kind of screws our design, but let's find some way of doing things here. So the render thing needs a deleter, and I believe that we have a sufficient deleter for it already. Let's see. Remove render, is that it? Yeah. Decal type of the not the syntax so decal type of the render goes right there. I'm going to get a pointer to that function. So that is the decal type of the renderer. We have the renderer here. We're going to initialize the renderer. So that is, I guess, add render. No, it is not add renderer. What is it then? Create, maybe? Create render. Nope, it's not create renderer either. Then what is it? Remove renderer. There should be something like create renderer, renderer. Init render. And we have, okay, so let's start here. We're going to add a header to actually C++ize their, like, make their interfaces compatible with C++. I don't like how their interfaces are. So let's make a header here. This we can use later on. So maybe you could call this the C++. Also, I'm going to use my own quoting convention here in the code, as you can see. Not there. So yeah, it is going to be a different naming convention. So let's make a new filter here. How many hours are we in? Maybe. I'm just getting carried away with this. This is the fun part to me. We have the header files here, what I'm going to add in it. Let's see. So alright, we're reconnected. So I was just renaming this. Are you sure you want to change it? Yeah, I am sure. Rename this what? .hpp, no. Yeah. So I'm going to call it render interface. Okay, render interface. So that's our render interface. I'm going to add that header here. So I'm going to write a new C++ interface for them. Add existing item. Not the src this time, but rather the include. That goes here, come here, remove everything. So, first thing, namespace. So what is it? Render, CVP, no, what should I call this? Render interface. So what I'm going to do here is actually have a renderer class. I shouldn't be writing whatever. Render class, render. Okay. So this is supposed to manage all the lifetimes we have. Okay. That is presumably going to uh, reduce some of the complexity here. Also, code is open to refactoring, so I don't think that is going to be a problem. Do we have a stud optional here? Stud optional. Let's include my. I believe that is all going to be included in my header. Let's see if I have stud option. I have a stud optional. That is nice. Show render. So you might ask why I'm using stud optional, because I need a lazy construction of my render. Okay, so what is the error here? This it has no member called optional. That is nice. Let's see. Let's undo these and see if their ESTL thingy like this. Let's see if this has optional. Does it? It does have optional. That is nice. So that's one reason to go with ESTL here, because of the optional. Let's listen. Just close something we actually need. Let's then go with the ESTL all the way then. Since I don't think, oh okay, I don't think ESTL is compatible with normal stud. So memory, no, not the memory unique putter. Unique putter. That is what we're going to use here. So our construction here. Let's make a public section for this public, and we're going to have ESTL unique putter. A unique putter of much time. Okay, we are already over time. Let's keep this for tomorrow. Yeah, because I believe I believe people are going to be interested in watching this actually. So it's not a bad idea to have this somewhere. Start this somewhere that people can catch up with. So the title of this stream is going to change tomorrow, and I am going to also get there, add this to my include directories. Let's get a compile and then finish this stream. Preprocessor definition, no. Code generation, no. Let's make this all configurations. VC++ directories includes. Okay. There are different executable reference, additional, there is additional library directories, no. Solution for platform, no. See what the values for this include path, include directory, include path. Hide that, does that work? No. Why does it tell me that they are different? Alright, because of that then, let's make it all. Let's add this. And we will solution directory, we will go run behind, then go to include, and then project name? Is that a thing? Dollar, do I have intelligence here? I believe that's going to work. Yes, save that. Project name. Let's see. Nope. Let's return a value. Let's also include my header here. What was it called? It's not included before the ESTL. I don't know. I really don't trust ESTL. I don't know what it is. I haven't seen people use it. So, what was it called? Renderer interface. .hpp. Let's see if this finds it. Oh, seemingly it does. Alrighty, we are done then. Okay, so from tomorrow on, I will work on this example. See you guys till then.